Hello everyone, welcome to new class. Today's class is about Basic Electronics Engineering. So, the Basic Electronics Engineering starts with the semiconductors. So, before that, the materials are classified into conductors, then insulators, and semiconductors. And based on their conducting properties, the conductors are usually good conductors of electricity. Insulators are bad conductors, and semiconductors have conductivity which lie in between that of conductors and insulators. And germanium and silicon are two most commonly known semiconductor materials. Next, we have to know about the energy band diagram. So, what do you mean by energy band diagram? The energy band structure of a solid determines whether it is a conductor, an insulator, or a semiconductor. So, energy band diagram means the range of energies possessed by electrons in a solid is known as energy band. And there are mainly three important energy bands. So the three important energy bands are valence band, conduction band, and forbidden band, also known as forbidden gap. Valence band. The valence electrons have least binding energy and more orbital energy. The range of energies possessed by valence electrons is called valence band. So these are about valence electrons. And conduction band. The valence electrons are loosely bound to nucleus. So here valence electrons have least binding energy. Here the valence electrons are loosely bound to nucleus. And when certain energy is given to the valence electrons, they become free. And these electrons are called the free electrons or conduction electrons. And the range of energies possessed by the free electrons is called conduction band. Then forbidden gap. The separation between conduction and valence bands on the energy level diagram is called forbidden energy gap. The energy which is required to lift an electron from the valence band into the conduction band must be greater than the energy gap. So, we can draw the diagrams. So, the classification of materials based on energy band diagram. The classifications are insulators, semiconductors, and conductors. So, in insulators, the forbidden energy gap is large. So, the insulators are those substances in which the valence band and conduction bands are widely separated, and the forbidden energy gap is greater than 5 electron volt, and examples are rubber, paper, mica, glass, wood, etc. Then semiconductors. The semiconductors are those substances in which valence band and conduction bands are moderately separated, and the forbidden energy gap is small and is of the order of 1 electron volt at room temperature. And at room temperature, some electrons in valence band have enough energy to surmount to the energy gap and get into the conduction band. At low temperatures, the valence band is completely filled and conduction band is completely empty. Therefore, a semiconductor virtually behaves as an insulator at very low temperature, and conductivity of semiconductors increases with temperature. So, conductivity increases with temperature, and they have negative temperature coefficient of resistance. Negative temperature coefficient of resistance, and examples are germanium, silicon, etc. Then conductors. The conductors are those substances in which the valence band and conduction band overlap. So we can represent like this, that is valence band and conduction band overlap. This is conduction band. So in this way we can represent, and here there is no physical distinction between the two bands, hence the availability of a large number of conduction electrons. And examples of conductors are silver, then copper, aluminum, then nickel, iron, etc. Next is classification of semiconductors. The semiconductors are classified into two types, intrinsic and extrinsic semiconductors. Let us study about intrinsic semiconductors. A semiconductor in an extremely pure form. So this is pure semiconductor. So a semiconductor in a pure form is known as intrinsic semiconductors. A semiconductor is not truly intrinsic unless its impurity content is less than 1 part impurity in 100 million parts of semiconductors. And let us know about these intrinsic semiconductors. And intrinsic semiconductors, examples are germanium or silicon, has only 4 electrons in the outermost orbit of its atoms. That is, if we consider silicon atom, then its outermost cell has 4 electrons. So only 4 electrons in the outermost orbit. And to fill the valence shell, each atom requires 4 more electrons. So to fill the valence shell means we need total 8 electrons. So only 4 electrons are there. So to fill the valence shell, each atom requires 4 more electrons. So these are the atoms. So each atom requires 4 electrons. Let us draw the structure. And this is done by sharing 1 electron from each of the 4 neighboring atoms. So consider this atom. So each atom has only 4 electrons in the outermost shell. So consider this atom, and to fill the valence shell, sharing 1 electron from each of the 4 neighboring atoms. So this atom also has 4 electrons in the valence shell. So here this sharing is done with each atoms. So the atoms align themselves in a uniform three-dimensional pattern so that each atom is surrounded by 4 atoms. So each atom is surrounded by this 4 atoms. So consider this atom. So this atom is surrounded by the 4 atoms, and such a pattern is called crystal. So this atom shares with these 4 atoms. Like that, each atom shares with the 4 neighboring atoms. And a silicon atom with its 4 valence electrons shares an electron with each of its 4 neighbors, and this effectively creates 8 valence electrons. So 8 valence electrons, and which produces the covalent bond. So this is covalent bond that holds the atoms together. Covalent bonding for germanium is similar because it also has 4 valence electrons in the outermost shell. And an intrinsic silicon crystal at room temperature absorbs heat energy from the surrounding air, and this causes some valence electrons. So here these are valence electrons. So these are the valence electrons. Then this is conduction hole. So when the silicon crystal absorbs heat energy from the surrounding air, the valence electrons gain sufficient energy. So these are valence electrons, and these gain sufficient energy to jump the gap from the valence band into the conduction band. They become free electrons and free to drift. So when they gain energy, these electrons move to the conduction band. So when an electron jumps to the conduction band, then it leaves a vacancy in the valence band. So let this electron jump into the conduction band. Let it be like this. So this electron leaves a hole, that is a vacancy in the valence band, and which is called hole, that is valence hole. And this hole behaves like a positive charge equal in magnitude to the electronic charge, and this electron has negative charge. So for every electron raised to the conduction band by external energy, there is a hole left in the valence band, creating what is called electron hole pair. So similarly, if this electron jumps into the conduction band, then it will leave a hole here, that is hole with positive charge, and this is the electron with negative charge, and which is called the conduction electron. So this is about the intrinsic semiconductors. So that is about the intrinsic semiconductors. So in the next class, let us discuss about extrinsic semiconductors. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.